Hey everyone, so today we're going to get into the nuts and bolts of the AI revolution. I mean the literal nuts and bolts. Because while everyone's talking about the software, the real fight, the next big thing, it might actually be happening on a factory floor. Let's dive in.
And that right there is the big question, isn't it? Because behind every mind-blowing answer from a chatbot or every incredible image you generate, behind all those trillion-dollar companies, there's something physical. There's actual hardware that makes it all work. All right, so let's start peeling back these layers. The AI we all use feels kind of like magic, right? It's just software out there in the cloud. But the truth is, it's a lot more real than that. And it all comes down to one single massive bottleneck. First things first, we've got to get this idea out of our heads that AI is just some abstract thing floating around on the internet. It's not. It runs on these incredibly powerful, super specialized silicon chips. We're talking GPUs, tens of thousands of them, all humming away inside these giant data centers. Without that hardware, the software is, well, it's just a bunch of code.
And here's where it gets really interesting. Every single one of those super advanced chips is made using a process called lithography. This is the technology that literally prints the microscopic circuits onto the silicon. It's what decides how powerful our future's going to be, and honestly, how much it's going to cost. Now, for the cutting-edge chips we use today, that whole process is pretty much dominated by one technology. It's called EUV, and it's controlled by a shockingly small number of companies. So the power structure here is, wow, it's incredibly concentrated. At the very top, you've got this Dutch company, ASML. They are the only company on the entire planet that can build these advanced lithography machines. Then, those machines are used by giants like TSMC in Taiwan to actually make a huge chunk of the world's best chips. It's created this massive bottleneck, both in technology and, geopolitics. The future of computing is basically in just a few hands. So what even is lithography? Okay, imagine you're trying to print an unbelievably complicated city map onto a tiny piece of silicon. The little roads on that map? Those are the transistors, the tiny on-off switches that are the heart of all modern computers. And these roads are thousands of times smaller than a single strand of your hair. Now, to print something that tiny, you need a very special kind of light and an even more special machine. This number you're looking at, that's roughly the cost of a single advanced EUV lithography machine from ASML. $400 million. I mean, just to put that in perspective, that's more than a brand new Boeing 787 Dreamliner. The barrier to entry here is it's practically a vertical wall. But what if there was another way? What if you didn't have to just keep building bigger, crazier, more expensive UV machines? Well, a little startup called Substrate is making a pretty wild claim. They think they can do it with X-rays. Okay, so here's the core difference, and it's actually pretty simple to grasp. With the current EUV tech, you're really pushing light to its absolute limit, so you have to draw the pattern onto the chip in multiple, super complex steps. It's slow and intricate. Substrate's idea with X-rays, which have a much, much shorter wavelength, is to basically stamp the whole pattern on there in one direct shot. And these are the numbers behind that big claim. Substrate is saying its X-ray tool can get a resolution that's just as good as the next generation of EUV, do it in a single go, and for a tool that costs a tenth of the price. Now, that little word, if. If they can prove these numbers at massive scale, that little if is doing some seriously heavy lifting right now. Because look, having a brilliant idea in a lab, that's one thing. But surviving the absolutely brutal reality of high-volume manufacturing, that's something else entirely. This is where dreams go to get tested, and, well, often broken. This quote just says it all, doesn't it? You can have the most amazing invention in the world, but in the chip industry, that just gets you in the door. The real war is fought on the factory floor. These are the metrics that make or break you. First, you've got yield. So, out of 1 million chips you make, how many of them aren't just expensive little duds? Then, throughput. How fast can you crank them out? After that, reliability. Can your machine run nonstop 24/7 for years with perfect microscopic precision? And finally, scale. Can you build a whole global manufacturing system around this thing? Yeah, these are the unforgiving questions that Substrate is going to have to answer. And what's really fascinating here is Substrate's strategy. Their answer to that huge challenge is pretty bold. They don't just want to sell the machine, because that would mean they're competing with ASML. No.
They want to build their own factories using their machines. And that means they're competing with TSMC. So they're not just trying to invent a new tool. They're trying to invent a whole new way of making things.
So let's zoom out for a second. Why should any of us care about this super technical battle over how to print tiny lines on silicon? Well, because the winner of this fight could have a massive, massive impact on the future of AI, on innovation, and even on geopolitics.
Think about the potential chain reaction here. It all starts with keeper manufacturing. If you can dramatically lower the cost of making these advanced chips, that leads to more innovation, right? Because more companies can afford to design and build them. And that in turn sparks faster AI progress, because better hardware always fuels better models. And what does it all lead to? More compute for everyone, expanding the global supply that the entire AI world is completely starved for right now.
Probably the best way to think about this is the SpaceX analogy. For decades, everyone just accepted that rockets were disposable. SpaceX came along and challenged that one single core assumption. Substrate, well, they're not inventing the chip. They're challenging the assumption that the only way forward is with bigger, more complex, and ridiculously expensive EUV machines. But just like SpaceX, success is going to mean years of brutal hard work and just mastering the art of manufacturing. And that brings us to the big takeaway. The next great AI breakthrough, it might not come from a new algorithm. It might not even come from a bigger language model. It might come from a factory floor, from some company that figures out how to bend physics and economics just right to print the future of computing more efficiently than anybody else. The race is definitely on.
Thanks for tuning in.